So you know Newton's laws of physics? You know, how when you drop something, it falls down? Great. Forget it. That doesn't happen when you become Ant-Man. Quantum computers. We're talking about quantum computers. That's what we are talking about. Yeah. Topic is scientific definition of quantum mechanics is the branch of mechanics that deals with the mathematical description of the motion and interaction of subatomic particles, incorporating the concepts of quantization of energy, wave-particle duality, the uncertainty of principle, and the correspondence principle. Basically, thingos are so tiny they act funny. Particles at a quantum scale are things that even the most powerful microscope can't see. Remember how tiny atoms are? Tinier than that. I'm guessing everyone knows how computers work. If you don't, computers use binary language that says if something is on or off, ones or zeros. Computers use gates to change an outcome, such as AND or AND NOT gates. You can combine a bunch of gates to create a specific outcome. Like if you want a computer to solve 1 plus 1, then it will translate that into binary, compute it through the gates, output another string of binary that the computer will translate as 2. The only reason we can make computers in the first place is due to being able to visualize the process and outcome, and know exactly what the outcome will be as well as the process. But quantum computers get a little silly with visualizing things. The biggest difference between quantum computers and computer is the process and the output. Quantum computers also use gates that take an input and change it into a desired output, but not like using normal ones and zeros. Quantum computers use percentages. What I mean by that is everything quantum computers is put on a you might get the answer you're looking for, but we don't really know. Imagine you want your computer to divide 12 by 2. Normal computers would do the basic algorithm and spit out 6, all by doing things in order. But quantum computers would instead already have the correct number, but also a bunch of incorrect numbers. It would take all the numbers, run them through a special gate, which is an algorithm that does something to numbers to determine if they are good numbers or bad numbers. If they are bad numbers, nothing changes, but if they are good numbers, then the computer raises the probability of it being the correct output. In this case, 6 would be a good number. It does this over and over again until you tell it to stop and look at the output. One thing to know is that the output is a superposition, which I'll explain later. This means that you can only look at the output once, and it stays that way no matter what. Because quantum computers output a set of percentages, there's always a chance that a quantum computer outputs 4 instead of 6. First time a computer would tell you 9 plus 10 is 21. All of those numbers are stored in things called qubits. Qubits are basically normal bits, but quantum. The government. The quantum computer you can never inhabit the passwords protected by government computers. Quantum computers can find passwords very easily. Even if it is very complex, it only depends on if you have the right way to find it and are willing to spend a long time finding it. Outside of that, people can use quantum computers to render information swiftly. According to Wikipedia, the largest supercomputer, EL Captain, has 11 million CPU and GPU cores? What? That's so expensive. What that means is you can process something that takes 11 million steps at the same time, which is called parallel processing. Basically, it's 11 million computers doing the same thing at once. A quantum computer does parallel processing naturally, so having 11 quantum computers could far exceed EL Captain. I'm sure most of you are aware of the 4 states of matter: solid, liquid, gas, and plasma. Plasma is where atoms and electrons are moving so fast they can't stick together. Well, it turns out Microsoft made a new state of matter. It's called the topological state of matter, and it's where atoms no longer define physically, but are defined globally. It's like having a digital avatar that is an exact replica. The digital avatar can die, but you are perfectly fine. Microsoft did this so that if any small disruption happens to the qubits, which is very common, there is a theoretical copy of it that can still work, and does still work. Now that you've learned what a quantum computer is and how it works on a surface level, you can use this knowledge to... Thanks for watching!